Welcome. And in this particular session, we will deal with op-amp as a differentiator. Mathematical operation, we know a differentiator means changing with respect to something. And when you say changing with respect to something, this can be with respect to time, so we call as a rate. It can be with respect to distance, we call as a gradient. So this mathematical differentiation option, we will be realizing using an electronic circuit, and that we will term as a differentiator. In a differentiator, the output, the circuit output, how is proportional to rate of change of input. So, if your input is changing at a faster rate, your output will be high. If your input is changing slow, your output will be less. So, output is proportional to dV by dt. How we will implement it? We will see it. So, how do we do then this? So we need to select an element which deals with time. Now which element is this? There are two elements which deals with time. One is a capacitor, one is an inductor. You know, in capacitor, charging and discharging. Inductor, how much EMF is induced, that depends upon the change of magnetic flux. So again, that is with respect to time. But inductor we normally don't use because it's bulky. Capacitor we use. So this is a circuit. We have my V input, and unlike integrator, we have the capacitor in the series path. And this is applied to an inverting terminal. Non-inverting terminal is grounded. So if non-inverting terminal is grounded, by default this becomes virtual ground. Let's say this is node A, and in a feedback path I have a resistance R, and this is my V output. Now let's analyze what's the scenario. So the current which will be passing through it is called as capacitor current. Now this capacitor current, when it comes at node A, it has two choices. One, it can enter into the op-amp, but we know, op-amp has a very high input impedance. So if something has a very high input impedance, it is not going to allow current entering into it. So the only option is the current to enter into the resistance IR, that is to enter into the feedback path. Now how much current passes through capacitor, that is given by C dV by dt. Which is the capacitor? D input dVi. You want to know how I calculated the capacitor current? It's very simple, fundamental. C is equal to Q by V, so Q is equal to CV. I differentiate with respect to time because rate of flow of charge is called as a current, and I got C dV by dt. So I is equal to C dV by dt. This is the current which will flow through capacitor. I am using same. What is the current flowing through? Resistance R. So this is my node A. Since the current is flowing like this, so it means it is going from high potential to low potential. VA minus V output upon R. So C dVi by dt. Oh, what is VA? If this is ground, this is virtual ground. Ground means 0. Therefore, RC into dVi by dt is equal to minus V output. That is what I wanted, right? V output is equal to minus RC dVi by dt. So my output is proportional to the rate of change of input. If my input changes very fast, my output will change, will be more. If my input changes slowly, my output will be less. And if the input does not changes, my output will be 0. There will be no change. How does it reflects? It will reflect like this. let's say this is a square waveform. Okay, now what will happen? If I apply this input, this square waveform at the differentiator input, so long as it is 0, input is 0, my output will be 0. But now suddenly my input changes, and if my input changes, I will get an output, but 180 degree out of phase. But then my input becomes constant. If input becomes constant, there will be no output. Suddenly my input falls down, changes 180 degree out of phase. So if you see, a differentiation of a square will give me impulse. This is an impulse. So normally we can use a differentiated circuit to find it out where to strike a chord wherever my input changes its state. And this is also called as another example. If we take, let's say, if this is my, in integrator lecture when I took an example of a ramp and a constant output. Let's say this is my input, a constant ramp, changing uniform, slope is same, here also slope is same, here also slope is same. So when the change is constant, what do you think output will be? It's the same. In integrator, integration of a constant will give me a ramp, but in differentiation circuit, the differentiator of a ramp will give me a constant output. Here also, if you see my capacitor, okay, and the capacitor, I know the impedance is given by 1 upon 2 pi fc. That is, it is inversely proportional to frequency. More the frequency, less will be the resistance. So if I have a high frequency component that can easily pass through it, but if I have a low frequency component, it will be blocked by the capacitor and will provide more resistance. For DC it will completely block. So out of high frequency, low frequency and DC, who can pass through the capacitor? Only high frequency. So this is why it is also called as a high pass filter. I hope you understood the differentiator circuit.